Now, in this lecture, we'll find out the area of rectangle ABCD using two different methods. In the drawing, we have rectangle ABCD. Inside rectangle ABCD, we have this circle that is inscribed by rectangle ABCD. Side PS equals to 6 units, 9 segment SQ equals to 5 units, and our mission is to find out the area of this rectangle ABCD. So because of the fact that ABCD is a rectangle, we know that all the angles inside a rectangle are right angles, so those angles are all equal to 90 degrees. Okay. We will define the center of the circle as point O. We will join points P and O together by a straight line. So here, point O is the center of the circle, point P is the point of the circle itself, therefore OP is the radius of the circle, so we define the radius of the circle as R. And here we have actually point P is the point of tendency BC with this circle, so I write it down. Point P is the point of tendency of tangent BC with this circle. Okay, and we have the radius that is drawn to the point of tendency. Therefore, tangent BC will be perpendicular to the radius PO. So if BC is perpendicular to PO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to rule number 1. Okay. And we also have the rule that if from the center of a circle we draw a perpendicular on a chord, then the perpendicular bisects the chord. So here from point O we draw perpendicular on chord SP. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and SP as point M, and according to the rule that I mentioned, here the perpendicular OM bisects the chord SP. That is to say, if SM equals to X, then MP must be also equal to X. Why? Because they are equal to each other. So we write down that SP equals to X plus X. SP equals to X plus X. So here SP equals to X plus X, that is 2X. SP equals to 2X, but it is given us in the question that SP equals to 6 units. So we can write down that 6 equals to SP equals to 2x, From this equation we will derive that 6 equals to 2x. We divide this equation by 2 and we get that x equals to 3 units. Here x equals to 3 units. So here x equals to 3 units. And here also MP that is equal to x equals to 3 units. Okay. We will define side AB of triangle ABC as A. We will define side BC of the side BC of rectangle ABCD as B. So BC equals to B, and B, it is actually the radius and the diameter of the circle. So here I write down that B is the diameter of the circle, because if you join the 2 points of tangencies by a straight line, it will pass for the center, and so whenever you have a chord that passes for the center of the circle, it is the diameter of the circle. So here, if we join points A and this point of tendency together, we get the diameter that passes for point O. Therefore, BC that is equal to B is the diameter of the circle. Okay. So if B is the diameter, then B over 2 is the radius. So R, the radius of this circle, will be equal to B over 2. Okay. In the next step, we'll define the point of tangency of tangent DC with this circle as point N. We'll join points O and N together by a straight line. Point O is the center of the circle. Point N is the point on the circle itself, therefore ON is the radius of the circle. That is equal to R according to our definition. So here again, the radius ON, it is drawn to the point of tendency. That is to say, it is drawn to point N, that is the point of tendency of tangent DC with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent DC will be perpendicular to the radius N. So if DC is perpendicular to the radius NO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. Okay, so we have here quadrilateral OP and C. Inside quadrilateral OP and C, we have 1, 2, 3 right angles, and the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actual angle ONP. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So here we subtract 270 degrees from this equation, and we will get that the missing angle ONP is equal to 360 degrees minus 270 degrees. It is equal to 90 degrees. It is a right angle. Okay, angle ONP equals to 90 degrees. This angle equals to 90 degrees. In the next step, from point Q, this point, we draw perpendicular on BC. Okay, here from point Q we draw perpendicular on BC. So this angle equals to 90 degrees according to our construction, and this angle also equals to 90 degrees according to our construction. Okay, we define the touching point of the perpendicular from point Q and PC and BC as point S. We define the intersection point between QS and QN as H. So actually we have here quadrilateral QP edge S. Inside quadrilateral QP edge S we have 1, 2, 3 right angles. And the sum of right angles is 270 degrees plus the size of this angle, that is actual angle O edge S. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, so here we subtract 270 degrees from the equation, and we get that the missing angle OHS is equal to 360 degrees minus 270 degrees. It is equal to 90 degrees. So this angle, it is a right angle, it is equal to 90 degrees. So actually, I found out that inside quadrilateral QP edge S, this quadrilateral, we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral QP edge S as a rectangle. So I write it down, quadrilateral OP, that's really OP edge S is a rectangle. Why? Because it has 4 right angles. And we know that the opposite sides of a rectangle are parallel to each other. Therefore, OP is parallel to edges. OP is parallel to edges. Repeat again. OP is parallel to edges according to the rule that the opposite sides of a rectangle are parallel to each other. But we also know that edge S is part of the perpendicular QS. Okay, edge S is part of the perpendicular QS. Write it down. Edge S is part of perpendicular QS, and the perpendicular is a straight line. Any perpendicular must be a straight line, therefore QS is a perpendicular, it is a straight line. QS is a straight line. So because of the fact that QS is a straight line, and we know that part of the straight line QS is parallel to OP, HP is part of the straight line QS and is parallel to OP. So if a part of a straight line is parallel to another straight line, to another line, it means that the straight line also itself, the straight line itself must be also parallel to that straight line. So because of the fact that edge S is parallel to OP and edge S is part of the straight line QS, it means that QS must be also parallel to OP. Therefore, we can conclude from it that QS, that is the straight line that contains edge S, must be also parallel to OP. QS is parallel to OP. Again, if part of a straight line is parallel to another straight line, the straight line itself must be also parallel to the other straight line. Okay, it is very logic, and so we know that QS is parallel to OP, and we have the rule that in front of alternating angles between parallel lines are equal to each other. So I write it down. The rule states that alternating angles between parallel lines are equal to each other. We can implement the rule that I mentioned here in our drawing, because those two angles are defined as some alternating angles, and they are located between the parallel lines OP and QS. Therefore, they are equal to each other. So I can write down that according to the rule that I mentioned, that angle SQP, this angle SQP, is equal to this angle, that is actually angle OPQ. Repeat again, angle SQP equals to angle OPQ according to the rule that alternating angles between parallel lines are equal to each other. Those two alternating angles are located between the parallel lines OP and QS, therefore they are equal to each other. So if we define one angle as theta, then the other angle must be also equal to theta because of the fact that they are equal to each other. Okay. So here we will focus on quadrilateral QSDC. Repeat again, we will focus on quadrilateral QSDC. In quadrilateral QSDC, inside this quadrilateral QSDC, we have 1, 2, 3 right angles. Repeat again, inside quadrangle QSCD, we have 1, 2, 3 right angles. And the sum of 3 right angles is 270 degrees, plus the size of the fourth angle DQS. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Okay, so here we subtract 270 degrees from this equation and we get that the missing angle DQS is equal to 360 degrees minus 270 degrees. It is equal to 90 degrees. It is a right angle. So this angle DQS is a right angle. It is equal to 90 degrees. So actually we found out that in quadrangle DQSC we have 4 right angles. Therefore quadrangle QSDC must be at least a rectangle if not a square. Okay, so we relate to quadrangle QDSC as a rectangle. And this again, quadrangle QDSC is a rectangle. Why? Because it has 4 right angles. And we know that the opposite sides of a rectangle are equal to each other. That is to say, side QS must be equal to side DC. QS must be equal to DC according to the rule that the opposite sides of a rectangle are equal to each other. But because of the fact that ABCD is a rectangle, side DC equal to side AB according to the same rule that the opposite sides of a rectangle are equal to each other. So we can write down that DC equal to AB because ABCD is a rectangle and the opposite sides of rectangle ABCD are equal to each other. So we found out that QS equals to DC equals to AB. So from this equation we will derive that QS is also equals to AB. QS equals to AB, but according to our definition, AB equals to A. Here, AB equals to A. So we can write here that AB equals to A. And from this equation, QS equals to AB equals to A, we will derive that QS is also equals to A. QS is also equals to A. Here, QS equals to A. Okay. In the next step, we will focus on the green triangle OMP. So I'll copy triangle OMP in a new page and we'll analyze triangle OMP. MP equals to 3 units, OP equals to B over 2, and this angle equals to theta. So this is the right triangle OMP. Let the copy from the original drawing. In the right triangle, triangle OMP. Cosine theta equals to MP over OP. Cosine theta equals to MP over OP. MP equals to 3, so we substitute MP by 3, and OP equals to B over 2, so we substitute OP by B over 2. Here we move 2 to the numerator and B to the denominator, and we get that here 3 over B over 2 equals to 2 times 3 is 6 over B. So in conclusion, according to equation number 1, we found out that cosine theta equals to 6 over B. Cosine theta equals to 6 over B, according to equation number 1. So here, in the next step, we'll focus on the right triangle, right big triangle, triangle QPS. In the right big triangle, triangle QPS, cosine theta, this will be equation number 2, cosine theta equals to QS over QP. Repeat again. In the right big triangle, triangle QPS, cosine theta equals to QS over QP. Okay. Cosine theta equals to QS. QS, we already found out that QX equals to A, so we substitute QS by A over QP. QP, what is the value of QP? QP equals to 5 plus 6. Here, 3 plus 3 is 6, and 6 plus 5 is 11. So QP equals to 11 units, so we substitute QP by 11. So in conclusion, we found out that cosine theta according to equation number 2 equals to A over 11 units. Cosine theta according to equation number 2 equals to A over 11. But we have already found out that cosine theta according to equation number 1 equals to 6 over B. So we have two different expressions for cosine theta. Therefore we create equation number 3 that states that cosine theta according to equation number 1 must be equal to cosine theta according to equation number 2. Okay, so cosine theta according to equation number 1 equals to 6 over B, and it must be equal to cosine theta according to equation number 2 that is equal to A over 11. So in conclusion, I found out that according to equation number 3, 6 over b equals to a over 11. Here we cross multiply this equation, equation number 3, and we'll get that according to equation number 3, AB equals to 6 times 11, that is 66. AB equals to 66 units. According to our definition, AB, that is the length of rectangle ABCD, equals to A units, and the width of rectangle ABCD, that is BC, it is equal to B units according to our definition. So the area of rectangle ABCD, it is equal to the length of rectangle ABCD, that is AB, times the width, that is BC. So it is AB times BC. AB equals to A and BC equals to B, so the area of rectangle ABCD is A times B, and A times B, according to equation number 3, is 66 square units. So in conclusion, we found out that the area that we are looking for, the area of triangle ABC, the area of rectangle ABCD, the area of this rectangle ABCD, equals to 66 square units. So we finished with the first method. In the next step, I will present to you the second method. So here, because of the fact that ABCD is a rectangle, all of its angles are right angles, so this angle equals to 90 degrees, this angle also equals to 90 degrees. This angle equals to 90 degrees. And this angle also equals to 90 degrees. We will define the length AB of rectangle ABCD as A, as we did in the first method. We will define the width of rectangle ABCD as B, so BC equals to B, and as I already mentioned in the first method, BC is also the diameter of the circle. I write it here that BC is the diameter of the circle that is blocked, that is described by this rectangle. BC is the diameter. Okay. So here, point P is the point of tendency of tangent BC with the circle. Here we will define the center of this circle as point O. We'll join points P and O together by a straight line. Point O is the center of the circle. Point P is the point of the circle itself. This is exactly the definition of our radius. That is to say, OP is the radius of the circle that is equal to R. As I already mentioned before, P is the point of tendency of tangent BC with the circle. and we have the radius OP that is drawn to the point of tendency, that is to say it is drawn to point P, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius PO. If BC is perpendicular to PO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. In the next step, we will do a construction. We will extend the radius PO until it intersects with side AD of rectangle ABCD. We will define the intersection point of the extended PO and AD as point N. So in rectangle ABNP, this rectangle, in this quadrilateral, we have 1, 2, 3 right angles. And I don't want to repeat all the same process again. The sum of 3 right angles is 270 degrees plus the size of the fourth angle must be equal to 360 degrees. And the end of the story, we'll get that this angle must be also equal to 90 degrees. So in rectangle in a quadrilateral A, B, and P, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So quadrilateral A, B, and P is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, side AB must be equal to side NP. Okay. Side AB must be equal to side NP, but side AB equals to A according to our definition. Side AB equals to A. If AB is equal to NP and AB equals to A, it means that NP must be also equal to A because they are equal to each other. Okay? Likewise, here in quadrilateral NPDC, we have 1, 2, 3 right angles, and therefore the fourth angle, this angle, must be also a right angle. Therefore, quadrilateral NPDC that has 4 right angles must be at least a rectangle, if not a square. Okay, and here we will join points A and S together by a straight line. Angle A is P. This angle is a peripheral angle. We define this point as point L. Chord LP passes through the center of the circle, that is point O, and any chord that passes through the center of the circle must be the diameter of the circle. So we can write down that LP, here LP is the diameter of the circle. So here we have peripheral angle LSP, this peripheral angle that rests on the diameter of the circle, that is LP. And we have the rule that any peripheral angle that rests on the diameter of a circle number one, any peripheral angle that rests on the diameter of a circle must be equal to 90 degrees. Okay, I repeat again on rule number one, any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. So here, this peripheral angle, angle LSP, rests on LP, that is the diameter of the circle, therefore it is equal to 90 degrees according to rule number one. Okay. So here, in the next step, we'll prove the big right triangle QNP is similar to the small right triangle LSP, this triangle. So why those two triangles are similar to each other? Those two triangles are similar to each other. Triangle QNP is similar to triangle LSP. First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So here, angle QNP is equal to this angle, that is angle LSP. Both those two angles are equal to 90 degrees, therefore they are equal to each other. I repeat again. Angle QNP equals to angle LSP equals to 90 degrees. In addition, before I continue, we'll define this angle as theta. So in the right triangle, triangle LSP, if this angle equals to theta, this angle equals to 90 degrees, this angle must be equal to 90 degrees minus theta. Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. For the same reason, exactly, in the big right triangle NPQ, this angle equals to theta, this angle equals to 90 degrees, therefore this angle must be equal to 90 degrees minus theta. So I will continue to prove that those two right triangles are similar to each other. Angle NQP, this angle, is equal to this angle, that is actually angle SLP. Both those two angles are equal to 90 degrees minus theta, therefore they are equal to each other. I'll repeat again. angle NQP equals to angle LSP equals to 90 degrees minus theta. And finally, angle theta is a common angle that belongs to both triangles, so angle theta equals to itself, or we can express angle theta in two different names. Angle theta equals to angle LNPQ because of the fact that it belongs to triangle NPQ. This angle NPQ is also equals to angle LPS. That is to say, it belongs also to triangle LPS. Repeat again. Angle NPQ equals to angle LPS equals to theta. So those are two different names for the same angle, that is angle theta. So we actually found out that triangle QPN, the big triangle, is similar to the small triangle, the small right triangle, triangle LSP, according to angle similarity rule. Repeat again. The big triangle QPN is similar to the small right triangle LSP according to angle similarity rule. And for the fact that those two triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that here side NP of the big triangle, the big right triangle, triangle NPQ, over SP equals to QP, that is the hypotenuse of the big triangle, over PL. Repeat again. Because of the fact that the two white triangles are similar to each other, we conclude that NP over SP equals to QP over PL. What is the value of NP? NP equals to A. You can see here that NP equals to A, according to what we already proved, that NP equals to A. So we substitute NP by A or SP. According to what is given as the question, SP equals to 6 units. Here SP equals to 6 units. So we substitute SP by 6, and it is equal to QP. Here, QP equals to 5 plus 6. Again, QP equals to 5 plus 6, that is 11. We substitute QP by 11 over PL. PL, as I already mentioned, here you can see that PL is the diameter of the circle, and then according to what we have already found out, that the diameter of the circle equals to B, that is the width of rectangle ABCD. So we substitute PL, that is the diameter of the circle, by BC equals to B. So we substitute BC, the diameter PL by B. So in conclusion, we found out that according to equation number 1, A over 6 equals to 11 over B. Here we'll cross multiply this equation number 1, and we'll get that according to equation number 1, A times B equals to 6 times 11, that is 66. So AB equals to 66. According to our definition, the length of the rectangle ABCD AB equals to A, and we also defined the width BC of rectangle ABCD is B. And we know that the area of any rectangle equals to the length of the rectangle times the width. The area of rectangle ABCD equals to the length of rectangle ABCD, that is AB, times the width, that is BC. But according to our definition, AB equals to A and BC equals to B. That is to say, the area of rectangle ABCD equals to A times B, and according to this equation, equation number 1, AB equals to 66. So in conclusion, we found out that the area of rectangle ABCD equals to 66 square units. Okay. So we finished with the second method. In the next step, I'll summarize the lecture. We start with the first method. So in the drawing we have rectangle ABCD. Inside rectangle ABCD we have a circle that is inscribed by the rectangle. It is given as the question that the length of PS is 6 units and the length of line segment QS is 5 units, and we know that ABCD is a rectangle, of course, and our mission is to find out the area of a rectangle ABCD. So in the first method, first of all, we know that because of the fact that ABCD is a rectangle, we know that all the angles inside a rectangle are right angles, so all those 4 angles are right angles. And here we define the center of the circle as point O. We join points O and P together by a straight line. Point O is the center of the circle, point P is the point of the circle itself, therefore OP is the radius of the circle. So the radius OP, it is drawn to the point of tendency, that is to say it is drawn to point P, that is the point of tendency of tangent BC with this circle, and whenever your radius that is bound to the point of tendency, then tangent BC will be perpendicular to the radius PO. So if BC is perpendicular to PO, it means that this angle equals 90 degrees and this angle also equals to 90 degrees according to rule number 1. Okay? Then we join points O and N together by a straight line. Point O is the center of the circle, point N is the point of the circle itself, therefore ON is the radius of the circle, and we have the radius ON that is drawn to the point of tendency, that is to say it is drawn to point N, that is the point of tendency, or tangent DC with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent DC will be perpendicular to the radius NO. So if DC is perpendicular to NO, it means that this angle equals 90 degrees, and this angle also equals to 90 degrees according to rule number 1. Okay, and so in quadrangle OPNC, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. Okay, and here, from the center of the circle, that is to say from point O, we draw perpendicular on chord PS. And whenever you draw perpendicular from the center of the circle to any chord, the perpendicular bisects the chord. Here, perpendicular OM bisects chord SP. That is to say, SM must be equal to MP. So if SM is X, then MP must be also X. So that is to say X plus X will be equal to SP. Okay, so here SP equals to X plus X, that is 2X. But according to what is given as the equation, SP equals to 6 units. So from this equation, 6 equals to SP equals to 2x, we derive that 6 equals to 2x, we divide this equation by 2, and we get that x equals to 3 units. So here, x equals to 3 units, and here also x equals to 3 units. Okay. Then, from point Q, we do perpendicular on BC. So this angle equals to 90 degrees according to our construction, and this angle also equals to 90 degrees according to our construction. As I've already mentioned before, in quadrangle OP and S we have 1, 2, 3 right angles. 1, 2, 3 right angles. Therefore, the fourth angle must be also a right angle. Therefore, quadrangle OP and S that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrangle OP and S as a rectangle. And we also know that the opposite sides of a rectangle are parallel to each other. That is to say, QP is parallel to edges. Okay. QP is parallel to edges because of the fact that the opposite sides of the rectangle are parallel to each other. Okay. But we know that edge S is part of the perpendicular QS. QS as a perpendicular must be a straight line. So QS is a straight line, and part of the straight line QS, that is edges, is parallel to OP. So if part of a straight line is parallel to another straight line, it means that the straight line itself must be also parallel to the other straight line. That is to say, the straight line QS must be parallel to OP. Okay, QS is also parallel to OP. And we have the rule that alternating angles between parallel lines are equal to each other. We can implement this rule in our drawing. Here, those two angles are defined as alternating angles, and they are located between the parallel lines OP and QS, and therefore they are equal to each other. That is to say, angle SOP equals to angle SPQ. And because of the fact that those two angles are equal to each other, it means that if one of the angles is equal to theta, then the other angle must be also equal to theta. Okay? So those two angles are equal to theta according to our definition. Okay? Then quadrilateral QSDC, this quadrilateral, has 1, 2, 3 right angles. Any quadrilateral that has 3 right angles, the fourth angle must be also right angle. Okay, I'm not repeating the same process. So the fourth angle, this angle must be also equal to 90 degrees, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral QDSC as a rectangle. This is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, QS equals to DC. QS equals to DC. But we also know that ABCD is a rectangle. And the opposite sides of rectangle ABCD equals to each other. That is to say, DC equals to AB. So we can write here that DC equals to AB. And from this equation, QS equals to DC equals to AB, we will derive that QS is also equals to AB. So QS equals to AB, but according to our definition, AB equals to A. So from this equation, QS equals to AB equals to A, we will derive that QS is also equals to A. Okay, we derive that QS is also equals to A. So here QS equals to A. Okay. Then we focused on the small right triangle OMP. I copied the small right triangle OMP in this new page. And we analyze triangle OMP. This angle is a right angle. MP equals to 3 units. OP equals to B over 2 units. And this angle equals to theta. So in this triangle, cosine theta equals to MP over OP. Again, cosine theta equals to MP over OP. MP equals to 3, so we substitute MP by 3. And OP equals to B over 2, so we substitute OP by B over 2. And we got here that cosine theta equals to 6 over B. So according to equation number 1, cosine theta equals to B 6 over B. Okay. And then we focused on the right big triangle OP QPS. This big right triangle QPS. In the big right triangle QPS, yeah, cosine theta equals to QS or QP. Cosine theta equals to QS over QP. Again, cosine theta equals to QS over QP. Okay. QS equals to A. So we substitute QS by A, and QP equals to 5 plus 6, that is 11. So we substitute QP by 11. So in conclusion, we found out that according to equation number 2, cosine theta equals to A over 11. So according to equation number 2, cosine theta equals to A over 11. While according to equation number 1, cosine theta equals to 6 over B. So we have two different expressions for cosine theta. Therefore, we created equation number 3 that states that cosine theta according to equation number 1 must be equal to cosine theta according to equation number 2. So here cosine theta according to equation number 1 is 6 over B, and it must be equal to cosine theta according to equation number 2, that is A over 11. So according to equation number 3, we found out that 6 over B equals to A over 11. Here we cross multiply this equation and equation number 3, and we found out that A times B equals to 6 times 11, that is 66. So AB equals to 66. And according to our definition, AB equals to A and BC equals to B. So the length of quadrangle of rectangle ABCD is AB is equal to A, and the width is BC, and this is equal to B. And the area of any rectangle equals to its length times its width. That is to say, it is equal to AB, that is the length, times the width, that is BC. AB equals to A, so we substitute AB by A, and we substitute BC, that is the width, by B. So in conclusion, we found out that the area of rectangle ABCD equals to A times B, and we just right now found out that A times B equals to 66. So in conclusion, we found out that the area that we are looking for, that is the area of rectangle ABCD, equals to 66 square units. We finished with the first method. Then I presented to you the second method. So first of all, as I already mentioned before, because of the fact that ABCD is a rectangle, all the angles inside the rectangle are right angles. So those four angles are all right angles. And we define the center of the circle as point O. Point P is the point of tendency of tangent BC with this circle. We join points P and O together by a straight line, so point O is the center of the circle, point P is the point of the circle itself, therefore OP is the radius of the circle. So we define the radius of the circle as R, and we have the radius OP that is drawn to the point of tendency. That is to say, it is drawn to point P, that is the point of tendency of tangent BC with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent BC must be perpendicular to the radius PO. So if BC is perpendicular to PO, which means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule number 1. In the next step, we did a construction. We extended the radius PO by a straight line until it intersects with side AD of rectangle ABCD, and we defined the intersection point or the touching point of the extended PO with AD is point N. Okay, so here we have P is the point on the circle itself. Here point L is also a point on the circle and chord PL passes through point O. Originally we extended PO by a straight line, so PL passes through point O, that is the center of the circle, and any chord that passes through the center of the circle must be the diameter of the circle. Therefore, PL is the diameter of the circle, that according to our definition it is equal to B. Okay, so here AP, it is also equals, that is the diameter of the circle, it is equal to B, because we already found out that BC, side BC, that is the width of rectangle ABCD, is also the diameter of the circle. We can also prove that BC is the diameter, but not at this time. It is very easy to prove that BC is the diameter of the circle. Okay? So here we know that PL is the diameter of the circle, and here we join points S and M together by a straight line. Repeat again, PL is the diameter of the circle. So here we have peripheral angle PSL that rests on the diameter. And we have the rule number 1 that states that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. So because of the fact that peripheral angle SP rests on LP, that is the diameter of the circle, therefore it must be equal to 90 degrees. That is to say, angle LSP equals to 90 degrees. In the next step, we define angle LPS as theta. So in the right triangle LPS, this angle equals to theta. This angle equals to 90 degrees, therefore this angle must be equal to 90 degrees minus theta. Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. For the same reason, exactly, in triangle QPN, this angle equals to theta, therefore this angle must be equal to 90 degrees minus theta. Then we prove that the big right triangle NQP is similar to the small right triangle, triangle LSP. So why those two triangles are similar to each other? First of all, so here maybe I will paint the small white triangle in the green color. The green triangle, the green right triangle is similar to the big right triangle, triangle NQP. So why those two triangles are similar to each other? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. In addition, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. And finally, this angle is a common angle that belongs to both triangles, therefore this angle equals to itself the common angle. So actually prove that all the angles in the green triangle can go into all the angles in the big right triangle NQP, therefore those two triangles can go into each other according to angle similarity rule. Okay? And from the fact that those two triangles are similar to each other, we conclude that the following relationship exists between their sides. We conclude that NP in the big right triangle NQP, NP over SP equals to QP over PL. Repeat again, we conclude that NP over SP equals to QP over PL. Okay, here NP equals to A. SP equals to 6 units according to what is given as the question. QP equals to 6 plus 5, that is 11 units. So substitute QP by 11. And finally, PL is the diameter of the circle that is equal to B. So I already mentioned before. So we substitute PL by B and found out that A over 6 equals to 11 over B. Here of course multiply this equation number 1, and found out that AB equals to 66. AB equals to 6 times 11, that is 66. So AB, the length of the rectangle ABCD, is equal to A according to our definition, and the width of rectangle ABCD equals to B according to our definition, and the area of any rectangle equals to the length times the width, the length AB times the width BC. Okay, so AB times BC equals to AB is A and BC is B, so AB equals to A times B. And A times B equals to 66 according to equation number 1. So finally we found out that in both methods the area of this triangle ABCD equals to 66 square units. Okay? Thank you very much.